So we now define a hyperbola. So what is a hyperbola? Hyperbola is the set of all points in a plane. So hyperbola is the set of all points in the plane, the difference of whose distances from two fixed points in the plane is a constant. So now we are talking about difference between two distances, and that difference is constant. So what is this distance? This is the farther point minus the closer point. So basically we will have two line segments, and we are talking about the difference between the longer segment minus the shorter segment being constant. Notice that as we move across hyperbola, the difference between the longer segment minus the shorter segment remains constant. So we are tracing the hyperbola. So let us write down. So we have two fixed points, say f1 and f2. The fixed points are called the focus or the foci, and we have a point P on the hyperbola. Then Pf1 minus Pf2 is a constant. So that is the definition. So the focus f1 is minus c0, focus f2 is c comma 0. We have 0 comma 0 is called the center of the hyperbola. This origin is called the center of the hyperbola. So the axis which contains both the focus is called the transverse axis, and the axis which is perpendicular to the transverse axis and passes through the center is called the conjugate axis. So we are labeling point A as minus a comma 0 and point B as a comma 0. Now we mark 2 points on the conjugate axis. These 2 points we are going to call as 0 comma minus p and 0 comma b. So let us define what is this b here. So we define b as square root of c square minus a square. Notice now this immediately gives us c square is equal to a square plus b square, and this is different from ellipse. In ellipse, c square is a square minus b square. So the length of the conjugate axis is defined as 2b. So the length goes from 0 comma b to 0 comma minus b. So now we want to find out what is this constant difference. We are saying the constant difference, which is farther point minus closer point, is a constant. That is Pf1 minus Pf2 is a constant. We want to find out what is this constant k. So let us work on it. So first step is you fix P equals to B. Then you have Bf1 minus Bf2 is k. Second thing, you put P as A. Now we have AF2 minus AF1 is the constant. So we are saying AF2 minus AF1 because it is longer distance minus shorter distance. And you can see in the figure AF2 is greater than AF1. So now you can look at the figure carefully. So first we will write BF1. So BF1, you can see in the figure now, is made up of BA plus AF1. Then we just copy minus BF2 down. We deal with the right hand side similarly. AF2 is AB plus BF2 minus AF1. Now we cancel out AB from both sides. So this would imply 2AF1 is equal to 2BF2, or AF1 is equal to BF2. Now the constant K is BF1 minus BF2. So BF1 is BA plus AF1 minus BF2. Now AF1 and BF2 cancel out. We are just left with BA. Now BA is nothing but 2 times A. You can stop the video here and look at the figure. The distance AB from minus A0 to A0 is 2A. So the constant difference is 2A. The eccentricity is given as C by A. So this is eccentricity of the hyperbola. Notice that the C in hyperbola is A square plus B square. This is very different from the C in ellipse, where C is A square minus B square in ellipse.